Hi everyone, welcome back to my channel. Today we are going to talk about chunking strategies in RAG systems. How we split our documents changes everything downstream. Chunking is the first step in the retrieval process, the ingestion that happens. First, the documents are made into smaller chunks. Each chunks gets embedded into vectors inside a vector database. And whenever a query comes based on the similarity between the words in the query and in the vector database, the relevant chunks are fetched. That is the retrieval step. All the retrieved chunks are then arranged based on the ranking and then given inside the context window for the LLM model. And then LLM processes the context and then it gives the answer. So that is the generation aspect. So the very first step is chunking. So it determines how the documents are being processed. So usually while chunking, a naive way is to do based on number of tokens, say 256 tokens. Then if it doesn't work, then try for 512. If not, then 1024. So it's not the most accurate way of doing things. We need to decide our chunking strategy based on the problem that we're trying to solve. Chunk is the unit your embedding model encodes into a single vector. So this is the vector that will be retrieved and it will be compared against the query. So it's important for us to have our chunks that are coherent. Each chunk should contain complete piece of information. It should not have half sentences or half information. The information present inside the chunk must be very specific. It should be small enough that its embedding reflects the content. Say we have a chunk that has 2,000 words. So it can have multiple points and information that can match multiple queries, but doesn't match one accurately. The information inside the chunk must be complete. It should be large enough that the whole answer is actually situated inside the chunk itself. Say we only have a 50-character chunk, it might not have all the relevant information of the sentence. So the problem here is, what is the smallest complete unit of information that can answer a query in my system? So this answer decides how we're going to do our chunking. So the most naive way to do is fixed size splitting. Say we give a certain number of characters for every character it gets split. It can be mid-word, mid-sentence, it doesn't really matter. So this has no awareness of logical boundaries. There are very less chances that the whole answer can be retrieved because it's cut midway. We don't know if the information is complete or not. It's only a starting point and works for unstructured documents. Next one is fixed size with overlap. Say we are going to overlap 15 to 20% of the chunk size. It is a little expensive because we are going to do 20% more API calls at ingest and we are going to spend 20% more on storage. But it's always worth it because we are getting relevant information. So due to the overlap, there's a connection between each chunk that we're not confused of what the next chunk is. So near duplicate context in retrieved results, and that's a better way of doing. So it's important to have overlap while chunking. Another strategy here is sentence-aware chunking. We use NLP libraries like NLTK or spaCy to detect sentence boundaries, and then we'll group sentences until a size threshold is reached. So the chunks are semantically coherent. There are no mid-sentence cuts, so that there's no information loss. The chunk size is variable length by design because we wouldn't always have 500-character chunks. So embedding model encodes complete thoughts. It's best used for narrative documents, FAQ entries, support tickets, transcripts, so where sentence boundaries carry some meaning. So limitation is grouping logic can still mix unrelated ideas if the sentences are short and the threshold is large. So it works best when individual sentences are already self-contained. Another type of chunking is structural or header-based chunking. If you have structured documents, say an MD file or an HTML file, the chunking can be done based on the headers and the content that is inside a particular section. So chunk becomes a logical section as the author intended. That's a most logical way of doing the chunking. Say we have a written policy section as one coherent chunk inside a particular document. So the whole thing is embedded in a single chunk. So whenever a query is made, all the relevant information is already present inside the chunks. So we're not losing anything. There are less chances of model hallucinating. Where we can use it, it's good for well-structured corpora, markdown documents, technical manuals, policy documents. When documents have structure, we need to use the structure and make chunks based on that. The most accurate way of chunking is semantic chunking. So the logic here is we are going to calculate cosine similarities between the vectors or the embeddings. Whenever the cosine similarity drops beyond a certain threshold, the chunk is broken down there. So all the relevant piece of information have similar cosine similarity, so they would be together. Whenever that drops down from a certain threshold, a next chunk is given from there. So the chunks change only when content actually changes the topic. There are no arbitrary boundaries, so there are no mid-thought cuts. This is the most cleanest way of doing chunking, but it's expensive. It's best for long documents without structural markers. Say we have n sentences, so n embedding calls it ingest. So this is going to consume more tokens, or say a little expensive than other type chunking strategies. Another thing that we can consider is multimodal chunking. Say in real world, we wouldn't have perfect documents when we're trying to build our systems. They're messier. We have PDF documents. PDFs contain tables, images, plain text. So how are we going to chunk? So we're going to do chunking based on the type of information that is present. Suppose we have PDF tables. So the entire table with column headers and row context have to be kept intact while doing chunking. Say we are going to follow a JSON format. Say this particular column has this particular value. So we're going to do that for each row. That's how we're going to, so that we don't chunk in between a certain row or a sentence. So logically, we have to maintain the chunking. Suppose if we have images and documents, there are multiple image embedding models that we can make use of. So the chunk would be the image and the information that is surrounding, the surrounding context that would also be embedded with that. Say it's referencing a paragraph, caption, or a model's description. So we're going to embed with that. Then we have, in general PDFs, we're going to use the specific libraries and do chunking based on that. So we're going to have a combination of all of these. Say PDF or tables would be chunked a certain way, images should be chunked a certain way. Then we're going to combine all of that and save that in the vector DB. So this is a very complicated way of doing chunking, but this would have the most meaningful information here. So every time the chunks are done at the boundary of complete and have answerable information. So that's about different chunking strategies that we can follow in RAG systems. Thank you very much for watching. Subscribe to my channel. Bye.